Welcome to our lesson on approximation. In this particular lesson, we are looking at the concept of writing a number in scientific notation. Scientific notation, which we have said scientific notation is also called standard form. Scientific notation is also called standard form. Now, as the name itself suggests, scientific notation, it means this is a notation. It is a way of writing or a way of noting a number. So scientific notation, the notation is given as A times 10 to the power n, where the A should be a number between the A should be a number between 1 and 10, the A should be a number between 1 and 10. It should be less than 10 in short. So we only write numbers so that they are between 1 and 10. All right, and the n is an integer, usually a positive or a negative power of 10. Now, I'll just explain in a moment what that means. So here, by scientific notation, what we mean is we want to express usually very large numbers or very small numbers in such a way that it is a number which is relevant enough within the boundary of 1 and 10. However, the value of the number itself has not changed. We have just written it in a way that is reasonable to the eye. Could be a very large number or a very small number, but we are writing it, expressing it as a number which is between 1 and 10. So this notation is the one that we call scientific notation. And if we look at an example, we can, for example, write the number 27,340. We can write this number in standard form. Now, this is 27,340, which means it's a very big number. It's bigger than 1. So, what we want to do is to write this 27,340 in such a way that it becomes a number which is less than 10. So, how do we write that? We pick the first non-zero digit and make it the only whole number component. So, the first non-zero digit, or the most significant non-zero digit in this number, is 2. We already know that since this is a whole number, the 27,340 is a whole number, which means the decimal point is way over after the 0. That is where the decimal point is. So by writing this number in scientific notation, we mean we bring this decimal point after the first significant figure so that it becomes 2.7340. Okay, we may include the 0 or not include it. We are going to clarify that. So when we write this number, which was 27,340, as 2.734, it means we have written it as a number which is less than 10, because 2.7 is a number which is more than 2 but less than 3. So we have written it as a number between 1 and 10, as our notation here indicates. But we now need to multiply by the multiples of 10 that show us how many place values we have put into this number to retain its value. Because as it is here, it is a number that is less than 10. But we need to multiply by multiples of 10 so that we don't lose the place values of this number. So we are going to say times 10 to the power. Now we count the number of place values that we have used up to bring our decimal point to somewhere between 2 and 7. And in this case, we have used up the ones, the tens, the hundreds, and the thousands, which means 4 place values. So in short, we are multiplying 2.734 by 1000 for us to be able to, by 10,000, because it has to be four zeros, 4 place values, a 0 under 0 here, 0 under 4, 0 under 3, and 0 under 7. That is the number of decimal places that this decimal point has to move for it to be in the same position without changing the value of the number 27,340. In other words, when we multiply 2.734 times 10,000, which means 1 and the 4 place values. When we multiply this number by the 4 place values, 1 and 4 place values, which is 10,000, we'll still have our number 27,340. So we have not lost the value of the number when we write it in scientific notation. When we write 2.734 times 10 to the power 4, we have not lost the value of the number 27,340. It is still the same. It is just the notation that we have changed so that we write it as a number which is less than 10. So that is an example of how we express numbers in scientific notation or standard form. Another example is if we have, for example, 0.00731. If we want to write this number in scientific notation or standard form, again we look for the first non-zero digit. The first non-zero digit is 7. So it means in this number we have to bring our decimal point to between the first 2 non-zero digits, so that we have a number which is less than 10. It should be greater than 1 but less than 10. So it means our digit is going to become, our number is going to become 7.31. Then 7.31 we say times 10, which should show the number of decimal places that we have moved. Now, since this is a decimal number, it's less than 1, and we have moved through 3 decimal places. We have moved through 0, another 0, and 7 for us to have the decimal point after 7. It means our power will be -3. The n will be -3. In short, what we are doing is we are dividing 7.31 by 1000, which means when we say 7.31 times, according to index notation, this is 1/10 power 3. The 10 power -3 is the same as that, which means it's the same as 7.31. It's the same as 7.31 times 1/1000 Now, this simply means we are dividing 7.31 by 1000. Alright, so when we divide 7.31 by 1000, it will still give us 0.00731. 0.00731, which confirms that we have not changed the value of the original number when we write it in standard form. So when we write this number in standard form, it is still the same, but we have changed the notation of how to write it. It now becomes 0.00731 on reversal. So the notation 7.31 times 10 power negative 3 is just a way of expressing the number in scientific notation. And sometimes we can add a concept of rounding off. We can combine rounding off and scientific notation. For example, if we say we write 0.279 in standard form, correct to 1 decimal place. If we say we write 0.279 in standard form, correct to 1 decimal place. So we know, first of all, in standard form, we have to move this decimal point to between 2 and 7, which means it's going to be 2.79. Now, when we have 2.79, we say times how many decimal places we have moved. We have moved the decimal point once to the right, which means we are going to multiply by 10 power negative 1, or we are dividing by 10. So this will be our scientific notation. Now, we have to express this number correct to 1 decimal place, which means our round off digit will be 7, and we look at the next digit is 9, which means we are going to increase the 7 by 1 unit so that it becomes 2.8 times 10 power negative 1. So we can actually combine the concept of rounding off and the concept of scientific notation in our procedure to approximate or to estimate a particular number.